Hey everyone, so today we are diving into one of the most wonderfully absurd scientific experiments I have ever heard of. We're talking about burning actual diamonds just to make some bubbly water. Yeah, you heard that right. I mean, what does a diamond taste like? It's a question you've probably never thought to ask, right? Because why would you? But what if you could take one of the hardest substances on Earth and turn it into something you could actually drink? Well, that's the bizarre, brilliant quest we're going to follow today. So you might be wondering, where does an idea this wild even come from? Well, it was actually inspired by this old school chemistry demonstration, the one that proved diamonds are just pure carbon by, setting them on fire. And that sparked a really simple and kind of hilarious thought. If burning a diamond makes carbon dioxide, could you, drink it? And this quote just perfectly captures the spirit of this whole thing. This was never about making some crazy luxury product. It was all about pure, simple curiosity. It started as a joke and turned into a real mission to find out what a diamond might actually taste like. And listen, this was not a cheap joke. The whole project kicked off with 4 grams of small, uncut white diamonds. Honestly, they looked more like tiny grains of sand than precious gems, but they still cost about $200. That's a serious investment for what was basically just a funny what if at that point. Okay, so with the diamonds in hand, the real challenges started to pop up. And there were 2 big ones. First, how in the world do you burn a diamond without completely melting whatever you're holding it in? And second, once you actually get it burning, how do you catch that precious gas? See, to burn a diamond, you need a ton of heat. And that's a huge problem. Regular glass, even the tough borosilicate stuff you find in a lab, would just turn into a puddle. The solution? Quartz glass. Because it's almost pure silicon dioxide, its melting point is ridiculously high. You could literally blast it with a torch, and it wouldn't even start to sag. And boy, did that choice of glass matter. The very first test run was, in their own words, a miserable and melted mess. But it was actually a successful failure. It proved that, yeah, the diamonds were burning. It also proved they were going to need a much, much more robust setup to handle it. All right, so problem number 1 is solved. We can officially burn diamonds inside a quartz tube. Awesome. But all that diamond-based CO2 is just floating away into the air. So how do you actually capture it? The answer is really clever and really, really cold. So they came up with this elegant 3-step system. First, they generate the CO2 gas. Then they purify it, bubbling it through water and salts to get rid of any moisture. But here's the masterstroke. They fed that pure, clean gas into a test tube that was sitting in liquid nitrogen. We're talking minus 196 Celsius. It's so cold that the CO2 gas instantly freezes into solid, dry ice, perfectly trapped. So now they can make little chunks of diamond dry ice. The project completely shifts gears from chemistry to straight-up engineering. They had to build a custom pressure chamber, something strong enough to turn that solid CO2 back into a high-pressure gas, and finally carbonate some water. And they did not mess around with this thing. It was basically bomb-proof. Built from industrial-grade stainless steel, this thing was massively over-engineered. We're talking a 3,000 PSI rating, pressure gauges, release valves, even an emergency safety valve, all to handle the insane pressure they were about to create. And they definitely needed that strength. Once they sealed the diamond dry ice inside that chamber, it started turning back into a gas, and the pressure just climbed and climbed, finally settling around 800 pounds per square inch. To give you some perspective, that is over 25 times the pressure you have in your car tires. Okay. And here's where the whole thing just gets hilarious. You have this heavy-duty industrial stainless steel pressure vessel, which they then literally zip-tied to the side of a regular off-the-shelf kitchen soda stream. It is the absolute ultimate high-tech meets low-tech solution. I love it. So, after weeks of hard work, after spending hundreds of dollars, after overcoming melted messes and engineering a custom pressure chamber from scratch, it all comes down to this: the final $1,000 taste test. The moment of truth. The final burn was an absolute marathon. It took over an hour of super careful torch work to turn the last of the diamonds into gas. The final yield? About 10.5 grams of pure, shimmering dry ice, ready to become the most expensive soda water in the history of the world. So the button is pushed, the diamond gas floods into the water bottle, the bottle gets capped, and the final verdict on this $1,000 beverage? It tastes, exactly like soda water. the perfect, most amazing anticlimax to this whole epic scientific journey.
Actually, wait, it gets even funnier. Because they just used basic filtered tap water from the office, the creator admitted it might have even been a little bit worse than regular soda water. Imagine all that effort for a slightly inferior tasting drink.
But of course, that anticlimax was the whole point. This entire elaborate, incredible experiment was just a beautiful way to demonstrate a fundamental truth. CO2 is CO2. The molecule is the same and its properties are the same no matter where it comes from. A diamond might seem all precious and special, but its carbon atoms are no different than any other carbon atoms out there.
And that kind of leaves us with a fun question, doesn't it? This experiment proved that sometimes the journey is way more important than the destination, and that science is at its absolute best when it's just driven by pure, unadulterated curiosity. So it makes you wonder, what other ridiculously expensive things could we turn into something totally ordinary?